Hi everyone, my name's Joshua and I'm excited to talk about how Hugging Face is bringing its AI ecosystem to the web with Transformers.js, an open source JavaScript library that allows you to run Hugging Face transformers directly in your browser. First up, a quick introduction. So what is Transformers.js? Well, if you know about Hugging Face's Transformers library, you might already be able to guess. But for those unfamiliar, Transformers.js is a library that provides high-level abstractions for running state-of-the-art pre-trained models in JavaScript. This means anyone can easily add machine learning functionality to their web applications. It's designed to be functionally equivalent to the Python library, meaning you can run the same pre-trained models using a very similar API. We also have an amazing open source community, with people from all over the world who really see the potential of machine learning on the web. In fact, last week, we had 150,000 downloads on NPM and over 1 million JS Deliver CDN requests. And it's been amazing to see what people have been able to build so far. Although the library is only around 6 months old, we've already added support for over 50 of the most popular model architectures, some of which you can see listed here. We also have over 400 ready-to-use models available on the Hugging Face Hub, supporting a wide variety of tasks across different modalities. So what's the purpose of Transformers.js? And why is Hugging Face exploring WebML technology? Well, I think the answer to that can be found directly in Hugging Face's mission statement: to democratize good machine learning. Democratize being the key word here. As you may know, Hugging Face maintains a large collection of open source machine learning libraries, including transformers, diffusers, datasets, and Gradio, just to name a few. However, these are all implemented in Python, meaning they aren't as easily accessible to, say, web developers, even though they make up a significant portion of software engineers. So, the goal of Transformers.js is to help lower the barrier to entry for web developers, and to help bridge the gap between web development and machine learning, ultimately making AI much more accessible. In addition to growing the community, the library aims to help developers build never-before-seen web applications. Whether it be real-time inference while a user draws something, or on-device processing of sensor data, Transformers.js serves as an easy way for developers to access the power of AI. As I'll show later on, it's amazing to see what's possible in a browser. When it comes to distribution, you simply cannot beat the web. Every time a new model or application comes out these days, the first thing people ask for is a web demo. The importance of a hassle-free, zero-install way for users to experiment with cannot be overstated. Models are hosted for free on the Hugging Face Hub, and devs can deploy a static website using something like GitHub Pages or Hugging Face Spaces, for example. The last point I've noted here, which certainly doesn't account for an exhaustive list, aims to highlight what this means for the end user. Combining on-device machine learning with the powerful APIs that browsers provide empowers users to take control of their data, and Hugging Face is a huge proponent of this. So how does it work? First, users can convert their PyTorch, TensorFlow, or JAX models to Onyx using Hugging Face's Optimum library, and this can be done in a single command. Of course, if the user wants to run one of our pre-converted models, they can skip this step and simply use the model ID from the Hugging Face Hub. Next, the user writes their JavaScript code. The easiest way to get started is with the pipeline function, which, as mentioned before, aims to abstract away much of the complexity behind machine learning. This means users can get things done without having to worry about how it's done. If a user would like finer control over the whole process, we expose the model, tokenizer, and processor classes, as well as other relevant functions. And finally, the user can open up a web browser and run their application. It's really that simple. With that brief introduction out of the way, let's jump into some applications that have been built with Transformers.js. First up is Blind Chat, an in-browser version of ChatGPT. Now, of course, the model we're going to be using, which is an instruction fine-tuned version of Flan T5, isn't as powerful as ChatGPT, but it still produces some pretty good results. Let's start by choosing one of the examples here. How about what is love? Since everything happens on device, when running for the first time, it will download and cache the model into the browser. And as you can see, not a bad result. Next, let's try asking it for some advice. How about, how can I become healthier? And after a few seconds, it gives us 8 pretty solid pieces of advice. Lastly, let's see if it has a sense of humor. How about, tell me a joke? Good one, little AI. As the name suggests, this project aims to demonstrate the privacy advantages of in-browser machine learning, since no data leaves your device. You can also imagine something like this being deployed as a browser extension to act as your personal assistant while you surf the web. And in this case, you don't need to worry about sensitive data like banking or passwords being leaked to some server. As models become smaller and more capable, I bet you'll be seeing many more examples like this very soon. Other than conversational AI, we also have examples of models which have been fine-tuned for a specific use case, such as code completion. Even when using a relatively small 300 million parameter model, it's still capable of producing high-quality results, as shown here. Another example of using large language models is for multilingual translation, and Transformers.js supports that too. In this demo, we're using Meta's No Language Left Behind model, which is a 600 million parameter model trained to perform multilingual translation across 200 different languages. Next application on the list, and probably my favorite, is Whisper Web, which is an in-browser version of OpenAI's set of Whisper models for automatic speech recognition. The user can select an audio file from a URL, from a file, or they can choose to record it using their microphone. For this example, I'll select one from the URL. Once the audio has loaded, you can click Transcribe Audio, and the model will generate a transcript for the audio you provided. After completion, you'll be given the option to either export as a TXT or as JSON. If you'd like to, you can select one of the other models from the dropdown, or select a quantized version if bandwidth is an issue. From my testing, even the quantized version of Whisper Tiny, which is only around 40 megabytes, still produces high-quality transcriptions. Whisper also supports multilingual transcription and translation, meaning you can select from around 100 different languages, either to transcribe or to translate into English. This example highlights the importance of on-device machine learning for sensitive sensor data like microphone or camera input. In many cases, users would prefer that recordings of their voice are not sent to some server, and rather that the computation happens on their device. Another interesting application is semantic image search. In this example, the user downloads a database containing 25,000 clip embeddings for various images from the Unsplash dataset. Once the database, which is only around 50 megabytes, has been loaded, the user can then search for images with natural language. Queries can be as simple as cat, snow-capped mountains, or more specific, like dog holding a stick in its mouth. Something I found quite interesting is that after loading the model and the database, it only takes around 50 milliseconds to compute text embeddings and perform similarity search across the 25,000 different images. And this isn't using any fancy vector database or anything, just plain old JavaScript. And finally, Doodle Dash, a real-time ML-powered web game that runs completely in your browser thanks to Transformers.js. The game is inspired by Google's Quick Draw, where you're given a word and a neural network has 20 seconds to guess what you're drawing. In fact, we use their training data to train our own lightweight sketch detection model. Don't you just love open source? In our version, you have 1 minute to draw as many items as you can, one prompt at a time. If the model predicts the correct label, the canvas will be cleared and you will be given a new word. Keep doing this until the timer runs out. Since the game runs locally in your browser, we don't have to worry about server latency at all. The model is able to make real-time predictions as you draw, to the tune of over 60 times a second. We also wrote a blog post and a tutorial covering the entire process, from training to model deployment, and I'd highly encourage you to check it out. As a final note, all the examples we just showed are open source, and you can find the code for each of them in the README. When it comes to building these applications, most of the time is actually spent on things other than machine learning, like user interface design, fixing bundler issues, and so on. This is because Transformers.js makes it extremely easy to add AI to your web applications. Let's take a look at how you can get started in just a few lines of code. For our first example, let's perform in-browser automatic speech recognition with OpenAI Whisper. The first step is to import the pipeline function from the Transformers.js library, which, in this case, is served from the JS-deliver CDN. Of course, if you're working with a larger project that uses a package manager, you can install the library with npm and then update the import accordingly. For simplicity, let's stick to using the CDN. Next, we will create an automatic speech recognition pipeline and specify the model ID from the Hugging Face hub as the second parameter. The last step is to pass the audio file to the pipeline. And that's it, just 3 lines of code to add state-of-the-art AI to your web application. When running for the first time, the model, which in this case is only around 40 megabytes, will be downloaded and cached in the user's browser. Subsequent runs will then reuse this cached model. You can also specify additional parameters like return timestamps, which in this case, by setting it to Word, will generate word-level timestamps for the transcript. You can also use one of the multilingual checkpoints to either perform transcription or translation into English. Next, let's test out a vision task, like object detection. Once again, we start by importing the pipeline function and creating an object detection pipeline. By not specifying the model, the library will choose the default one, which in this case is a lightweight object detection transformer from Facebook. We can then pass an image to the pipeline and optionally specify other parameters like threshold and whether to return the bounding boxes as percentages or pixels. The output of the pipeline is JSON, which contains information about each object detected in the scene, including the confidence score, the label, and the bounding box. With the machine learning side of things out of the way, we can add some code to allow the user to upload an image and to render the predicted bounding boxes. And that's it. We have successfully built a simple but powerful object detection website in less than a minute. For those interested, we published an interactive video and step-by-step tutorial which covers the user interface code in more detail, and you can check it out in the documentation. As of today, we support 21 different pipelines, and we're continually working to add new ones. For example, we recently released text-to-speech support, which provides a significantly improved and far less robotic voice than the current built-in browser speech synthesis API. Here's a side-by-side comparison between the two.
This is text-to-speech with the built-in speech synthesis API.
And this is text-to-speech with Transformers.js.
And just last week, we added super resolution and image restoration. To find models which are compatible with Transformers.js, you can navigate to hf.co/models, then select the Transformers.js library from the Libraries option on the left. You can then filter by task to narrow down your search. Once you've found a suitable model, you can visit its model card, which will provide you with information about its usage. The full list of supported tasks, along with example code to help you get started, can be found in the README. Another question you may ask is, where can you use Transformers.js? The main category, of course, is websites and progressive web apps. With no installation required from an end user, it's clear why building websites and applications for the web has become the go-to place for many developers, and now hopefully for machine learning applications in the future. This is especially true considering the plethora of browser APIs made available to web developers in a safe and sandboxed environment. Another benefit is that you don't even need to worry about server costs. Like all the demo applications shown earlier, you can export your application as a static website and use free hosting like Hugging Face Spaces or GitHub Pages. Of course, if developers are not willing to completely switch over to static websites, using a hybrid approach can certainly alleviate some costs. After all, the web is the perfect place for distributed computing. Enhancing the browsing experience with ML-powered extensions is also a seriously popular choice for developers. It's also a massive positive for privacy and security, since none of your data is shipped off to other servers for processing. Here's an example of a browser extension which was made by a community member to index research papers. It uses Transformers.js to generate text embeddings, allowing the user to search using natural language. Thanks to on-device AI, you can still use the extension offline, and none of your data is sent to an external API or server. Although Transformers.js was not originally designed for server-side and desktop applications, it quickly became apparent, thanks to the many GitHub issues for Node and Deno support, that there was a massive demand for this. And the rationale is simple. Developers want to use a language they're familiar with, which is why backend JavaScript has become so popular. Additionally, the ability to create ML-powered Electron applications shows how powerful the library can be in the hands of developers. Another interesting use case of Transformers.js is ML inference on the edge. More specifically, Transformers.js can be used in edge functions, which are small, lightweight pieces of code that are deployed to the edge of a network, allowing them to perform specific tasks at very low latency. Superbase has a great article on this, where they show how to generate high-quality text embeddings in edge functions using Transformers.js, and I highly recommend you check it out. Next, let's say you've trained your own custom transformer model that you would like to run in the browser. How would you go about making it compatible with Transformers.js? As I mentioned earlier, the first step involves converting your PyTorch, JAX, or TensorFlow model to Onyx using Optimum. The easiest way to do this is with our conversion script, which is included in the repo under the scripts subfolder. After cloning the repo and installing the necessary dependencies, you can run the following command, replacing the model ID with the ID or path of the model you'd like to convert. For this example, I'll convert this very popular Roberta model, which has been fine-tuned for financial news sentiment analysis. Once the conversion process has completed, you can upload your model to the Hugging Face Hub by visiting hf.co/new, entering the model name, and then clicking Create Model. Next, navigate to the Files section and click Upload Files. Here, you will be greeted with an interface where you can drag and drop the model files that were just created. After the files have uploaded, you can add the Transformers.js library tag to the model card. This will make it searchable for other users who may want to use your model. Finally, we can test it out with Transformers.js. For a change, let's build a simple Node.js script this time. After installing the library with npm, we proceed in the usual way. First, importing the pipeline function. Second, creating the text classification pipeline, specifying the task as the first parameter, and the ID of the model we just created as the second parameter. Lastly, we can perform sentiment analysis by passing in a piece of text and then running the script from the command line. The model will be downloaded and cached on the first run, and then reused for all the following runs. And now you know how you can run your own models with Transformers.js. It's really that simple. So where does that leave us? And what's next for Transformers.js? Well, first of all, we'll continue adding new tasks and models, aiming to achieve feature parity with the Python library, at least for the most popular use cases. Next, and definitely the most anticipated update, is for WebGPU support. As of last week, Onyx Runtime Web now ships with an experimental WebGPU backend. And after we do a bit more testing, you'll soon see WebGPU-powered apps being built with Transformers.js. Currently, due to protobuf and WebAssembly limitations, Transformers.js models are capped at 2 GB in size. This means we can't use some of the most popular large language models out there, like Llama 7b. Fortunately, efforts are being made in the community to work around these constraints. We also aim to improve integration with, and perhaps guide standards for, the next generation of web browsers, where scientific computing and AI APIs take center stage. For example, one can imagine a browser-based web store for models, similar to the Chrome or Firefox web stores for extensions. From the user's perspective, they could search for web-compatible models on the Hugging Face Hub, install it with a single click, and use it across multiple domains. Currently, Transformers.js is limited in this regard, since models are cached on a per site or per extension basis. Anyway, that's all from me today. Thanks so much for watching. I look forward to seeing what you build with Transformers.js.